Okay, so this is proof by induction on question 9. Prove that a plus d, so this is basically arithmetic sequence, guys. A1, that's t2, that's t3, and that's tn. And what we want to prove that equals to this formula here, which is Sn for all values of n. Now what we have here is the equal sign, so the tn's represent the t's represent the left hand side, the s's represent the right hand side. So what we're going to do is we're going to test p of 1. Okay, so when we test p of 1, we're going to get test p of 1. So p of 1 is t1 on the left hand side, that equals a. On the right hand side, that means replace n equals 1, so we're going to get half times 2a plus 1 minus 1 times d. 1 times 1d is 0d. A half of 2a equals a. So this is true for p of n. They're both true, as LHS equals RHS, true for p of 1. Now, once you've done that, what you're going to do next is you're going to do step 2, which is assume true for p of k. True for p of k. This basically means that n equals k. So let's replace n with k. We're going to get a plus d, in brackets, a plus 2d. And then we're going to go all the way up to a plus n minus 1 times d, or a plus k minus 1 times d, and that's going to equal k over 2 into 2a plus k minus 1 times d. Now, part 3 of this question is proof for p of k. So, we do here, we're going to prove for p of k. So, prove for p of k plus 1. Now, when you prove for p of k plus 1, it's once again a plus d, plus the k term, so that's t of k. That will be in t3, t2, and t1. So tk is going to be a plus k minus 1 times d. Now we have to find the k plus 1 term, so we need to replace k with k plus 1, and we're going to get is plus a. Now imagine this is k plus 1, it's going to be k plus 1 minus 1, and k plus 1 minus 1 is just k, so a plus kd, close bracket. Now equals, replace k with k plus 1, and we're going to get k plus 1 all over 2 into 2a, and then we're going to get k plus 1 minus 1, like 2a plus kd. Now, on the left hand side, we can see that these first couple of terms, they all equal, this is all equal to p of k. So we can replace p of k with this part here, which is going to be k over 2 into 2a plus k minus 1 times d, all plus a plus kd, equals bracket k plus 1 into 2a plus kd all over 2. So that's the right hand side, and this here is the left hand side. Once again, going to work on the left hand side, and what we're going to do is I'm going to put this one over 2 and 2 on the outside here. I'm going to multiply out, so you're going to get 2ak. Then we're going to get, when we multiply this in, it's going to be kd minus d. Then multiply that by k, and we get k squared d minus kd plus 2a plus 2akd all over 2. Now, what's going to happen is they're going to interact, and we're going to have is 2ak plus k squared d. Now it's going to be kd plus 2a plus kd. In a second. Okay, so this part here actually had no a in it. So if we just undo this part here, when I multiplied 2 by kd, I'm getting 2 kd, so there's no a there, so it's just 2 kd. So it's minus kd plus 2 kd, so it's going to be plus 2a and minus 2 kd all over 2. Now, what we can do here is we can factorize the left hand side. We can take out k into 2a plus kd. Now we're going to get so k into 2a, and that's plus 2 kd minus kd, so it's just going to be plus kd. So that part there is plus kd, and then it's going to be plus now it's going to be a 1 into 2a plus kd. So what we're going to get all over 2, we're going to get is k plus 1 to 2a plus kd all over 2. And that's our left hand side, and this equals the right hand side. As the right hand side is the same thing. So LHS equals RHS, and then hence P of k plus 1 is true if P of k is true. And then hence by the principle of mathematical induction, P of n is true. Okie dokes. So, this question 9 is done.